Again, in this video we continue our studies of inequalities, and in the first video, as you remember, we revised the signs, the basic signs, which you can see here. In abundance, it's greater than or equal to, it's less than or equal to, and what we are discussing here is of extreme importance. It's a topic which is you can find it everywhere in further Algebra 1, Algebra 2 courses, and actually everywhere at university. I mean, at college, as I have to say. Here in Russia, it's university. Well, anyway, what we are going to master is double inequalities, so to speak. Let's concentrate here. We will be using three different types of notation. The easiest is graphic notation. It's just well, when you have a number line, and on this number line you draw. On this number line you just draw. Let me adjust a little. This means all numbers on a number line between A and B. But what is the most interesting is the ends, the points at the beginning and at the end of this segment, because those points are just so-called filled circles. And this means that we include the boundaries. So sometimes it's closed, finite and closed, like it's written here, finite and closed. There is an interval notation. Here it's called just interval. Here it's interval notation, where you put square brackets to show that you include those points. You also consider them. And if we write a double inequality, it means that at the same time x is less than or equal to b, and at the same time x is greater than or equal to a. So it's possible that our x is equal to a, as well as it is possible that our x is equal to b. Now, the next thing, finite and open. This is more difficult to understand, but well, we don't have to fear. We have to try to get used to it. When the circle is not filled, like here, so it looks like an empty dot, it means that we don't include the boundaries. It's finite and open interval. So we only consider the interior of this segment. And it means that our signs are less than, x must be at the same time less than b and greater than a. And unlike the previous case here, x can't be equal to b anymore, and x can't be equal to a anymore, because both points a and b are excluded from our consideration, excluded from this interval. We can combine case 1 and case 2. For example, here it is combined finite and half open. One side is closed, one side is open. So when the interval is closed, the dot is solid, it's filled, it's colored inside. If it's open, it's just the circle, and it looks like an empty circle, like a hole. And in Russian it's called, we pin out the dot. There is some terminology. So here we have, in this case, let us draw again. Here we have, this one is solid, it means colored, it means we include A at the beginning of this interval. And this one is empty, it means that we don't include B. And vice versa, the opposite. We don't include A here, and we include everything inside, and we include B. So both intervals are finite and half open, but they are half open at different sides. This one is open at this side, and this one is open at this side, closed here. Then we have a tricky symbol, which looks like an 8 lying down, horizontal 8. The symbol is actually infinity, and this one is an infinity. It's exactly like 8, just lying down, not standing, but lying down. Forgive me my stupid joke. Okay, but anyway, this is just a limit. There is no infinity in reality. Infinity is a notion. Infinity is an idea. And that's why we can't include infinity in our interval. That's why it's always, when infinity is present, it's always open. It can't be closed. We don't actually mark it in any way. Here we see, here you see, from infinity, and it's an open side, from negative infinity to B, and we include B. Closed, B closed, included. Let me draw it properly. When we draw it, we, small technical irregularity here. When we draw it, we just draw it up to the end of our number line. But here we include B, because it's half closed interval. And when the other side is closed, then we have, in this case, we have positive infinity, and we include B in our interval. So the same can be done differently. Both ends could be open. Infinity, as I said, is open, always open, but B, it's our choice, either closed or open. And here B is open. It means I just draw a circle. And here A is open. I just also draw a circle. And the first one means any number from a negative infinity up to B, but we don't consider B. B is excluded. It's an open interval. And in the second case, we start with A, but we don't include A. X can't be A. X can be anything A a little bit greater than A. And then it can be significantly greater than A, because it goes to positive infinity. And when we mean the whole number line, another way to express it is just to write an open interval. It would be infinite from negative infinity to positive infinity. In this case, this actually means that X is any real number. Any real number, and there is a shorter notation of this, but now we're discussing this. In this case, I might draw it like that. Well, everything is shown again here. You can see all possible examples This is open and infinite. This is also infinite but closed in this case. 4 is included. In this case, 4 isn't included, but it's going to the other side. And in this case, 4 is included, and so on. When we see both ends of our interval, we write a double inequality, and we see both ends. There is no need to write negative infinity. That's why in case of infinite intervals, or half infinite, so to speak, we don't write infinity here, just x is less than or equal to 4, and that's it. So we write those double inequalities, and it can be written like that also. And as you see, it's set builder notation. Set, it's just a term which means a number of objects. Actually, everything is a set. A number of people in a classroom is a set of people, and a number of tables, and so on and so on. Builder is an obvious term. We're building sets, constructing them. Well, a notation is a notation. And again, it's interval notation here. So we can write in my worksheets. I employ a little bit different notation for OR here. What is written here? X is less than -1, or x is greater than or equal to 4. It can be written in another form. I could draw such big, it's like a square bracket, and it means exactly, it means OR. When I write here 2 lines, it's a questionable thing, which is easier to either to draw this or to write OR as a word OR. But I want you just to know both forms of notations. So in this case, it would be one line, x is less than -1, and the next line, another line, is x is greater than or equal to 4. These two things mean absolutely the same. Absolutely the same. Sometimes I will be using this notation for you to get used to both of them. This, sometimes this, sometimes this, sometimes this. Let us see a few words about possible mistakes when we deal with intervals and these notations. What possible mistakes can we make? Everybody makes mistakes. It's like everybody pays taxes, which I mentioned in my on my front page. Me, of course, me included. I make mistakes. You can hear my pronunciation mistakes sometimes. I hope there are not so many of them, but you know, it's impossible. Sometimes you mispronounce in your native tongue, sometimes you mispronounce in whatever language you are speaking. Okay, so possible mistakes in maths. For example, let me draw your attention to the fact that the beginning of the interval, okay, let us consider a closed interval. It means we include both points. But I would just leave empty places. If I, for example, if I put here a number which is greater than this one, for example, 5, 4, it wouldn't make sense because my number line always goes from left to right, actually. And I have to follow my number line. So this is incorrect. I can't put a bigger, greater number here. No, no, sir. No, man. I must reverse them. it would be from 4 to 5, not from 5 to 4. So with indignation and other feelings, I write the correct thing, 4 to 5. Similarly, if I write x is less than 4 and greater than 5, would it make sense? X is greater than 5, for example, 6. But at the same time, it must be less than 4. 6 isn't less than 4, isn't equal to 4. So this doesn't make sense. It's worse than absent. It's a mistake. So we have to avoid, we have to follow the number line. We have to always control, this is less than this, less than this. So our sites should be ordered. By the way, it's not an easy task when, for example, you have square roots, you have, it can be complicated. So we, in some difficult cases, we have to control it separately. But we won't have anything difficult here. Of course, we want to start with simple things, and we're going to, go step by step. So this is mistake number 1. And actually, this is the only mistake we can make. Other mistakes they consider, oh, maybe another one is to draw a square brackets with infinity, for example, negative infinity square brackets. It doesn't make sense because actually I saw such notations, but we're not going to discuss them. And in our for our purposes and in our considerations, we won't even touch this subject. So in our case, negative infinity and positive infinity, they're just ideas of the ends of our number line. We can go to them infinitely, and we would go and go and go. It's like going around the globe. So this is it. We don't include negative and positive infinity. We always order the sides of our interval, the beginning and the end of our interval, and that is it. Then we have just to be careful. Just to be careful. It's a good idea when, for example, I haven't mentioned another important sign. And this is the last thing. This looks like big U, this, but actually it is a sign which means end. It's logical end. And so it's unification. Why U? Because it's unification. Unification of two intervals. So it means exactly what is written here. From negative infinity to negative 1, without including it, open interval. We can say the word open. And we can, when we're reading this, we can say end. Or unified, but it's end is much easier. And from positive 4 to positive infinity. From positive 4, we can say open. Open to positive infinity. So here, a good idea is to follow always from negative infinity and write all our intervals in order. If we encounter a strict teacher, he or she will be very angry with us if we actually violate this order. And in a difficult problem, when we have to write our answer properly, we have to be careful here. And that is it. Those are all the secrets. And the only thing which is left is to get used to it. And that's why I prepared some worksheets, which I will happily present to you for your implementation. Actually, you'll have to write one notation is written, either graphic or set builder notation or interval notation, and the rest you should figure out yourself. Here they go. Just a second, my software waits. Here. So doing this at home, you have to, for example, this is written, and this is set builder notation. You have to write interval notation here, and to draw it. When you draw it, of course, don't use the color. Just use your pen, and how to draw this thing which I drew in color. Let us do it together. We have only black pen, and this is a finite interval which starts with -1, but it is open. It means that I draw a circle around -1, then it ends at 3, which is closed, so I color it. Then I have a choice. I might just draw such a thing, beautiful, round. It's one option. Another option is I can just make it like that. Just draw some kind of sign, just to like a spring, to put like a spring. So what you like more, you choose. Some people, by the way, doing this, are doing this like this. You can also put a lot of slashes here. Whatever you show, I don't think it's a good idea to color it like this, because it doesn't look neat. And theoretically, it's also possible, but as for me, I would stick to this one because it's neater. And when there are a lot of them, a lot of intervals, you just somehow the easier to graphically perceive it, the better. So see you in the next video, and we'll train doing those intervals together.